thanks to the opportunity to present our contribution on an open research topic that is receiving a great improving from AI algorithms. The topic. Perché non va?
Penso sia alla fine della presentazione. La slide che...
Era
l'ultima.
No, aspetta. Sorry. Sorry. Okay. The topic is the 3D automated reconstruction for HBIM. We are interested in generating not
Mara,
a simple...
devi condividere lo schermo, Mara.
Scusa. Allora, sorry. Ok. Condividi. Scusatemi, eh. Ok, perfect. Now it's okay? Okay. Sorry very much. Okay, sorry. The topic is 3D automated reconstruction for HBIM. We are interested in generating not a simple 3D model, but an HBIM, a model with information, as you know. We can define two main steps in this process. The first step is point cloud automatic segmentation that is based on AI algorithms application. And the second step is automated HBIM model generation from semantic point cloud segmentation. Our research is an interdisciplinary research that we have done with the University of Naples Federico II, University of Bergamo, and University of Bradford especially for AI application for point cloud segmentation. Now I'd like Victoria Cotella could continue the presentation.
Thank you very much, Professor Capone, for the introduction. And I would like to take the opportunity to thank Pietro Azzola that he is with us. So thank you very much. So I will present the research problem. So as we usually know, in the pipeline scan to BIM, the main gap is about how to go from the segmented and classified point cloud to the heritage BIM. This usually we solve it with the manual BIM modeling, that this is a really time-consuming process. And so we are here to try and to set a stepping stone in the research about how to solve this problem. The next, please. Several research has been carried out in this field. For example, here we have really interesting work in the Villa Adriana Tivoli, where the researchers applied different machine learning algorithms in order to represent, in order to achieve different scales of representation of the wall patterns. The next, please. This is another case of the Temple of Neptune in Paestum. They use the criteria about the different architectural elements in order to train and test the AI classificator. As we can see in the left picture and in the right picture, we can see the already segmented and classified point cloud. The next, please. This is several solutions has been arise about how to come from the already segmented point cloud to the BIM geometry, but this solution has been addressed to buildings that are relatively new. For example, this is an office building where the researchers use through artificial intelligence some algorithms or parallelism or orthogonalism. Of course, that is impossible to apply to cultural heritage because it's impossible to find these characteristics. The next, please. And this is a very interesting research about the application of the visual programming techniques in order to reconstruct different complex geometry regarding to the cultural heritage. The next, please. And on the other hand, we have some, of course, also some already developed works where they start from the point cloud, and they also use the visual programming language in order to reconstruct the geometry, in this case, going through Rhino and ArchiCAD. So this has been some solutions, some kind of type of solutions to solve this problem. But of course, the field needs a lot of investigation. So the next, please. So in our case, our pipeline work start from the data acquisition process. We start applying these digital survey techniques like the terrestrial laser scanning, terrestrial photogrammetry, and also aerial photogrammetry in order to have to achieve the 3D raw point cloud. Why raw point cloud? Because this point cloud just only have RGB characteristic, the color and the positioning in a coordinate system. So that's why our next step is to classify first of all, and after that segment it, applying different AI algorithms. In this sense, our first step is to extract the mainly geometrical features. After that, to label our training and testing set in order to build our data set. After that, we train the model. In this case, we choose a multi-layer model in order to take the best from each machine learning algorithm. So we create a mix of everyone, taking the best of each one for each class. So this is an overview of our projects. As I mentioned before, so we have the school of Crespidadda, our case of study, and we took the window in order to segment it and match it with the coordinates present in the BIM library. The next, please. Our case study is the school and theater on Crespidadda. So Crespidadda is UNESCO site, World Heritage Site, located near Bergamo. The next, please. And this is the first result of the digital survey that I mentioned before, was carried out by using the TLS, terrestrial laser scanning, aerial and terrestrial photogrammetry. The next, please. So in this step, we start with the pre-processing data in order to build our data set. So we calculate by using the cloud compare the geometrical features, so the covariance features from the RGB point cloud. So we do this with a radius of 0.2 meters in order to achieve a better accuracy in the whole point cloud. The next, please. After that, the data set was divided in training, testing, and prediction. So the training and testing set was labeled manually with the following criteria that you can see in the left picture. So to each class was assigned a scalar field in Cloud Compare. The next, please. And here we can see an overview of the step-by-step. So in the first image, we have the manual data labeling, so the training and testing set together. So we more or less use 80% for training and the 20% for testing. The second image, we can see the prediction results in the unlabeled data. And the third one is a representation of the overlay. So training and testing model, training, testing, and predicted model. The next, please. Okay. So in this step, we say, okay, let's take one element from the one already segmented element in order to develop the BIM library. So we choose the window. The next, please. Okay, this is the video. So we developed the window family in Revit, so as traditional techniques. So we could focus, we could detect that the window is the same with some parameter that's turn on and turn off. So we decide to use, in this case, the traditional Revit family to do this step. Okay, so the next, please. Okay, perfect. Now I will leave the floor to Professor Mara Capone to finish this step. Thank you very much.
We are testing another different approach that is based on HBIM element generation using VPL approaches based on geometry feature. The main goal is define a VPL visual programming language script capable of generating different architectural elements in a semi-automatical way. We are testing VPL interoperability in Revit in order to automatically position the custom architectural element in the point cloud segmentation to automatically generate the HB model. This is our testing, some testing to do this. And we are testing some processes based on coordinates to place automatically the element. This is our conclusion. Outstanding issues in cultural heritage as a research focus for automation in geometric reconstruction of the building, hypothetical morphological reconstruction of the historical asset, information database, digital support of conservation, and so on. The main problem is has come to be because an HBIM automatic construction from point cloud segmentation classification. Until today, there is no effective methodology that allows this to be done. So we think that it is very important a testing activity in this field. Thank you very much for your attention.